Hello, everyone. Welcome to Logic for Ontologists, number 4. Okay, so today what we're going to do is we're going to talk a bit about ontologies in an automated workflow, like ontology engineering and development, and it's really semi-automated workflow. And this will lead naturally into discussion of SPARQL. Before we get there, though, because I don't want you coming in here with lazy brains, I want you ready to go, to think hard and carefully. We're going to do a little warm-up exercise first with a murder mystery. Are you guys familiar with the game Clue? Are you familiar with the movie Clue? This is from the movie Clue. It's a murder mystery, right? Who done it? You have all these features you're investigating, and all these pieces of information are being delivered over the course of an evening. You have to figure out who done it. Was it the butler with like a hammer in the basement? Stuff of that nature. You make guesses, etc. If you played anything like the game Werewolf, somewhat similar to Werewolf, so you're trying to find the wolves. Incidentally, and I want this recorded so that everybody knows, Werewolf, that game should have been spelled W-H-E-R-E. What a missed opportunity. You're trying to find a werewolf. Anyway, so that is Neil. Varying faces. But here's the mystery that we'll be attempting to solve. A psychologist has been murdered. Neil has it in for psychiatry. Suspects are Werner Cloisters, Mark Jensen, Neil Ott, and Barry Smith. Well, what we know, Mark plays the violin. Neil, Mark, and Barry daydream. Barry can't play music, but reads and solves problems. Werner never daydreams. Mark doesn't solve problems. Werner plays trumpet and problem solves. Neil cannot play music and cannot read. The murderer daydreams and is either a musician or literate and solves problems. Your task first is to represent these facts in Protégé. And then pro tip, I'll have you create a murderer class that's equivalent to line 9. And if done correctly and you've spelled out the facts in 1 through 8 in Protégé well enough, when you hit the reasoning step, you'll push a button and Protégé will tell you who the murderer is. Yeah. Go forth and model in your Protégé. Feel free to ask me questions.
I'm up. All right, bear with me. All right, got it.
Okay, cool. For context, I just had all 4 of my wisdom teeth taken out, so that's why I sound like this.
I'm amazed you're even here.
Thanks.
Right.
I've got my full-time job too to catch up on, so it's a rough week. At subclass.
All right, so we got Werner. Mark, Neil, and then Barry. And then I had instruments, but we can do hobby because that may be higher up. But first one is violin. Then there's like a play music. I don't know what that constitutes.
Okay, hold on. So play music.
Yeah.
Play violin. Here, wait. I'm gonna do this. Music.
We have they do and then they do not. So we have like inverse relationships here, I think.
Not music. We'll figure that out later. Hold on. I just want to put the actual hobbies first.
Okay.
Reads.
Can it have a suggested?
Okay, what else is there? Daydream.
Daydreams. Play music.
It slows me down. So
I mean that's
What's
reads.
literate agrees. Okay, so they're not literate, they don't read. Okay. So music, not music.
Yep. Reads.
You should have the option of turning it on and off.
Cannot read, so we have an inverse. Solves problems, does not solve problems.
You should have like an auto break.
yeah.
I mean, I think we just get them and then we'll move them around.
I don't know. I'm thinking I'm like traumatized from last time when we forgot how we spelled everything. So problem solves.
Yep.
Okay.
We'll just take a picture of
Trumpet.
it next time. Yep.
What else is there? Okay, so we have violin, daydream, music, reads, solves problems. Trumpet, music, cannot read, is a musician or literate and solves problems. Okay, so relationships. That's not music. This is music. That's a hobby. Murder class suspect. Okay.
Let me give some pro tips while you guys are noodling. So when when you want to represent relationships between things, there are two broad ways to do it. You have object properties, you have data type properties. So the object properties, you use object properties when you care about reasoning over the instances of things and how they relate, the pairs. When you care about those relationships, for instance, you want to reason about Mark playing a specific violin, or that Mark plays something of the type violin. And you want to potentially infer information, not just about the fact holding, but about Mark in that violin. Data type properties, you use those when you want to, when you're using data types, right? Like integers and stuff, because they have logic built in to the data types. But more generally, like in the case of the data type properties that are related to strings, you use those to represent facts. But you can think of it as facts, just the fact that Mark plays a violin. When you don't need to actually do any reasoning over the violin or Mark, but just the fact that there's a playing going on. And the way you'd represent this is saying something like Mark data type property plays violin, true. Or, as in this case here, Mark problem solve, false. So some observations. Really, there's one, I'll reiterate what I said earlier about the difference between using object properties and data type properties. So if you, and I will recall, object properties relate instances of things to instances of things. And so if you are to representing its case in the relationships among these facts, you're going to be representing them, things like plays, as a relationship between Mark and something else. To do so, you need to introduce like a specific violin or a class of violins, which Mark can bear a relationship to instances of. That may or may not be valuable depending on whether you need that to reason. So the reason you use object properties is because you want to reason or infer information about the instances that are related to one another. Data type properties, you use those in two cases. One, when you're using data types like integers or booleans or something, because there's a logic built into them already you can rely on. Two, more generally, and by more generally, I mean what I'm about to say encompasses the data type usage. You use data type properties when you want to represent facts. That is to say, when you want to reason about just the facts rather than things that are parts of the facts, like the instances that comprise the facts. This is a scenario in which it's a lot easier to just work with facts than the instances. You can represent Mark playing a violin as having a plays as a data type property that is related, whose range is Booleans, which would be to say, if you put Mark, if you represent it as number 2 in this way, you would say something like the instance Mark bears the plays data type property to true. And similarly, this is important because like when you get to 6, if you're using object properties, you're going to get yourself into a little bit of a bind. Data type properties, with this, you could just say Mark problem solved false. Easy peasy. Data type properties, straightforward way to represent the fact Object properties though. How do you represent this? Well, remember, in OWL, you can't link instances to classes. You have to link them to instances. So you could go a couple of ways. You could say that Mark bears the not problem solve object property, or Mark bears the object property problem solve to nothing, or something like that, like some instance nothing. In the second case, you'll have to introduce something like a null thing, a non-thing. If you're going to do that, just use false. If you're going to do it the first way, where you build an object property, this is marked not problem solved, you still have to relate it to something. What is the thing? You can either, the only real option is to introduce a specific problem, which is false, right? It's not exactly accurate. It is not exactly the case that Mark doesn't problem solve this specific problem. It's that he doesn't problem solve any of them. So the difference is like saying John doesn't drink Dr. Pepper versus John doesn't drink that Dr. Pepper. Does that make sense? So again, this is all reason to think, especially by the time you get to 6, it's representing the facts. Is kind of probably what you're best or better aimed at, rather than instances.
And do you want to be careful how much you put inside of an object property?
Yeah, so you should always remember, just as Jay is pointing out, when you put anything you put in an object property name, like in this case, like not problem solved, that is opaque to the reasons. Computer doesn't know what not means embedded in a name. That's not how it works. We know. You can't the machine won't reason on that. It's not picking up the label. It doesn't know, for instance, when you give a class like or a class like the label dog, that it's also a mammal. You have to say that. You have to assert a relationship between them. Same here. You'd have to assert the relationship of not playing or not problem solving. And that's what I mean. When you spell it out, what are the options you have relating to a specific instance? Like that's something the machine can read, it can reason over, but it's also false, right? Or at least it's not true in the way that we want it to be for this case. Is it? You want to add anything, Jay?
Yeah, so wouldn't you want to make sure that you have maybe active problem solving as a process, and you are saying Mark, not active problem solving, and even more specific, if you had an instance of the problem, the active problem solving, you'd even want to relate it to that, because obviously instances can't relate to classes.
Mm-hmm.
So you would have to have an active problem solving, and then you would have to have a instance of the active problem solving, which is the problem he's trying to solve. And you could just say problem solve generic X or something.
You could say this, but I think you'll get into that same bind I was just referring to with having the instances. So if Mark's not, I mean, what does it mean to say that John or Mark is not engaged in active problem solving? You'll say, like, you'll spell it out, like using like negative object property, for instance. We could use that. You'll say, Mark bears the negative object property, or say participates in active problem solving. So that's true. What that means so far, what that means though, is that Mark does not bear the participation relation to some active problem solving, but not just some active problem solving, a specific active problem solving that you have to add to the domain. Just like when you say John doesn't drink Dr. Pepper, what you have to say if you're going to approach it this way with like a negative object property is to say there is a specific Dr. Pepper and John doesn't drink that one over there. What we do want to say is John doesn't want to drink Dr. Pepper in general, or Mark doesn't problem solve in general. And so to get there, because we can't link instances directly to classes, like the class of problems, we can't say that Mark is not related to it.
Okay.
Well, a better way to say, or like a cleaner way to say, is to just use data type properties.
Okay. Use data type properties. Interesting.
It's just
Would you also say
facts,
that, like, if
right?
I did have to create an object property, I just want to make sure that I properly subclass it under a known object property?
If it's reasonable, like we have these conversations in a relations group a lot, but because that sort of hierarchy.
People like to make them up all the time and then they
They
don't
do. And we
subclass
definitely
them.
want to encourage them not to and like find a place, but we also like the people for many years haven't spent, or very few people have spent a lot of time thinking carefully about the hierarchies we have with object properties. And so it's,
Or anytime.
yeah. Yeah. Like, and
So if I wanted to do the data type, right?
Mhm.
What would I do? How would I model that?
Oh, yeah. So you have in the case, like if we're just sticking with Mark, we'll say Mark problem solves or doesn't problem solve. You'll have a data type property that says it's just solves problems or problem solve. And then it'll be related to as its range, the range will be a Boolean, so true or false. And then you can link that to Mark so that you can say Mark related to through problem solves. So just Mark problem solves as a data type property, and then just say false. And what that's an object, or that's a data type property assertion that says Mark doesn't solve problems.
And he could have an unlimited amount of data type assertions.
That's right. Oh yeah. He does. He's a complicated fellow.
Do you mind if we go through like how to physically input that into Protege? Because I'm trying to do it right now, but I'm not sure if I'm doing it right.
Yeah, I would, but I'm gonna move on.
Okay.
But I'm gonna give time at the end. So this will be part of the staggering, thinking about something, making you think about something, making you come back. So we will come back to this before the end of the class, and then we'll walk through it then. Is that okay?
Yes, thank you.
Delightful. Now I'm gonna share my screen. Okay, can you guys see my screen?
Yes.
Delightful. All right, so I was gonna give you some space to do this one, but we'll work back after that. So now now that we've warmed up a bit, let's talk about the Common Core ontologies at a high level, a repository. And for those of you typing away, working on the problem that we were just working on, recall, multi-focus, directing your attention back and forth quickly. Part of the practice is attend to what I'm saying now. I know it's hard, right? It's sticky. That's the point. So we will talk now about the Common Core repository. So we will talk later about Common Core, BFO and Boro and Dolce. I've moved that down to later. So what is CCO? It's a widely used suite of 11 ontologies. Consists of logically defined generic terms and relations among them reflecting entities across all domains of interest. It extends down from the basic formal ontology, and it is being directed for use as baseline of one of the baseline standards by the DoD and the IC. BFO is the other. It is currently being evaluated as a mid-level ontology standard, analogous to BFO as a top-level ontology standard. This one, rather than being as ISO, is by the IEEE Standards Association under PAR 3195.1. If you want to know more, you can ask the chair. That's me. I can tell you more about it. Now, here's the link to the GitHub repository, which is what we'll be talking about today. I said 11 ontologies. Here they are. We'll get more familiar with them later. I'm just kind of giving you a lay of the land, but we cover things like geospatial, ontological representations, information, time, agents, qualities, units of measurement, currencies, facilities, artifacts, and then various object properties that you might have among these things, or data type properties too. You see over here we have contributors. There's some familiar faces. Neil is over there. Mark. This is the Mark I keep talking about, by the way. That's him, Mark Jensen. You have Ron Rudnicki, who is the kind of founder, creator of Common Core ontologies, who is now retired. You also see Olivia and Greg Fowler. They're pretty regular contributors to Common Core ontology. And here's a little snippy diagram illustrating the relationships of basic formal ontology through the extended relation ontology, which is where the object properties, data type properties are for Common Core, linked to the various other ontologies that sit under in the whole suite, which we call a Common Core ontology. This is useful. BFO is very high level, very general, continuance processes, etc. What we want is some more specific guardrails And so Common Core extends down from BFO, giving more specific content as we get closer and closer to the ground. Comes equipped with various design patterns to help users build so they don't have to reinvent the wheel. Because we know what happens when you reinvent the wheel. It's not interoperable with other wheels that others reinvent. So we try to give these guardrails. There's a wheel metaphor here to make sure that people are modeling roughly similarly to one another. Here's a design pattern representing graduation and the acquisition of an academic degree in the Common Core. Here's one representing credentials, social security numbers, driver's licenses. Here's one representing deployment or pattern, or here's one representing employment for a software engineering role. Again, guardrails for ontology development. This is, if you're navigating to the repository, you'll see it here. This is what you'll see. There's Neil. Neil's been merging some stuff in. There's Greg. As you see, Neil has just recently merged a pull request from Greg. You'll see documentation sources. SRC is where you'll find the ontologies. You'll see some other stuff. We're going to talk about the make file today in this .github, some of the content of the .github directory. But yeah, this will be familiar if you navigate to the repository. There's that merge request I was talking about, but just at a high level, the workflow is pretty simple. What goes on is there's a main branch on GitHub where the releases are. If you go back here, you'll see this says develop. This is the develop branch. It's the default branch. That's where that's where people fork from to make updates and changes. So again, releases are up there at the top on the lead branch, main here, sometimes called master. There's also a develop branch that sits off of, or like comes off of it, and then people fork from there, make changes, and then commit those changes back to the develop, and eventually, when enough changes or enough time has passed, we merge those changes from develop into the main branch, and then we cut a release, the new release. So 1.5 is the current release, and 1.6 will be coming out, I think, Tuesday. So if you're looking on the repository page, as I said, you'll see this reflected. There's the develop branch. You can also click this little down arrow if you want to look at the master or the main branch. I think it is called master. There you see. And I'll note here what I'm saying. The master branch is 220 commits behind develop. That's what I mean. Like the changes are going on in develop, and then we merge them back into master and cut a release. Okay, what happens when we do this? What happens when you fork and you make changes to develop? What happens when develop is merged into master? So we have leveraged GitHub's actions, a GitHub Actions workflow, so that we can automate the building of the files that we're interested in updating. So GitHub Actions, we're leveraging this to create workflows to build and test and draft releases for the ontology in an at least semi-automated way. And I won't walk through all the details. I just want to highlight some of the key points so that you understand what's going on. You'll see there's a YAML file here that's under this .github directory and under workflows. And it's got some content over here like name, build, test, draft, release, which you'll see reflected in GitHub Actions. GitHub Actions, incidentally, is where you can go see the successful or unsuccessful builds that have run. You get like a little check or an X, depending on how it went. You'll also notice some things here like this is set up so that when somebody pushes a change or update to the develop branch, other things happen. What other things? Let me show you by looking at this make file, because this is where those things are described. It's messy. Make is terrible to read. I'm not a fan. I borrowed this from Tim Prudham and James Overton, who did a lot of work on like creating make files for ontology, the engineering. And so some things I want to highlight here is you'll see the various ontologies I'd referenced earlier in the 11 herbs and spices that compose Common Core ontologies. You'll see like geospatial facility ontology. You see those named here. each of those is checked. More specifically, though, I didn't put this in the slide. What happens is somebody creates a change and makes an update on the develop branch to one of these files, like the facility ontology file. First, a lot of like quality control checks are run against the facility ontology. Also, a reasoning is done to see if it's consistent. Then the facility ontology is merged with the other ontologies in the suite. Quality control checks are conducted. Consistency is checked again to make sure that nothing subtle was introduced in the facility ontology that undermined one of the other ontologies. And then if all of those checks are fine, it goes through and we can add it to the development.
Are those QC checks automatic or is it manual?
So they are automatic, but we're gonna, as you'll see in a minute, we're gonna get our hands dirty making some more.
Are those all just available on their GitHub?
They are. I'll show you exactly where they are too, right? In just like 5 minutes. That's exactly where we're headed. But before we get there, I just want to point out is we're using Robot, or at least a version of Robot that Tim has stripped. The Robot itself is an OBO Foundry tool. It was created and focused and targeted on OBO, open biology and biomedical ontology Foundry ontologies. Rebecca Jackson, I believe is her name. She did a fantastic job creating this tool, but it basically runs reasoning checks. It allows you to automate like targeting SPARQL queries, for instance, to run quality control checks. It can do some import module creation or generation and checking. It can create various release reports or editing reports. It's a pretty varied toolkit. Now I'm going to focus on the SPARQL query parts and the build and release part. So that's what I would like for you guys to help with. If you're running a build and develop, you'll see, and this is where if you recall, I was talking, you could like click on the actions page, you see a little check mark or a little X. You can click on those check marks or X and you can see what happened in the build in GitHub. This is what you will click on, or this is what you would see if you were to click on such a build. It's kind of messy, right? Like, but you'll notice, look, you see it's reasoning on agent ontology, reasoning on artifact ontology. It's going through the modules. Important for our purposes, there are quality control checks, as I've mentioned, that are being run against the files during the reasoning step. As you'll see here, they all, if you can read that, you'll say that there is a SPARQL query that requires that there is at least one English definition for certain things, like classes, object properties. And you'll see here that there are 86 violations on the OWL files that we have in the repo. And you'll see which ones. Has aunt, has brother. Now, you'll also see warning. I'll show you how that populated in a minute, but I'll note if you click on these links, it will take you to an XML page in your browser where you'll find information specifically about that object property or that class. That's what these IRIs resolve, right? They resolve in your browser if you click on them.
Is that that's RDF XML right there, right?
Yeah, it's right there at the top. You see RDF.
Are you guys running your SPARQL, your reasoners through RDF XML files or through turtle files?
Turtle files.
So RDF XML does something really funny. So if you have, say you don't have your import closure, what RDF XML will do is it will say, like, say you're subclassing off something that's just an IRI, it'll make a full statement. And then the reasoner reads that and says, oh, you're missing an RDFS label here in English because it doesn't have anything. Where if you're dealing in SPARQL, it doesn't have to do that because,
I see. I'm glad we're just using
Yeah. So when we do RDF XML and then we run it through like agent, it comes up because we don't have import closures. We just have individual files. They all violate this.
Gotcha. Oh, that's interesting. Okay. That's good to know. I'm going to keep that in mind. I actually haven't been playing around with the reasoning associated with the XML, the RDF XML, because I find it so aesthetically distasteful that I cannot.
Well, the worst thing is, John, if I build a file and
Mhm.
I originally built it without imports, and then I go bring the imports in, I have to go back through that RDF XML file and delete all of those blank IRI statements because they'll be there, even though I don't need them anymore because I have the import now.
Yeah. Oh, that's cool.
Annoying.
Yeah, this is just a lesson. Don't do that. Don't use turtle. Well, okay, look, these 86 violations I was pointing to. What does this mean? All right, go in that .github directory. There's another file. There's another directory called SPARQL. You've got a README here that tells you how these SPARQL queries that are listed here are supposed to be formatted. But you'll see things like deprecated properties, duplicate label, duplicate definition, and also minimum one English definition .sparkle. And you see at the top, it says there's a definition that's required. Any class or object property must have a non-empty definition with an English tag. An XSD English tag, right? And the severity of this is a warning. You can have a severity being error, which is like stop everything, don't do anything else, break the build. Warning is like go on, but remember, it's like yellow light, not red light. And then the rest of this is SPARQL. Dun dun dun. Before I go there, though, Giacomo had his hand up.
So you run SPARQL queries through Rob.
Robot's running and it calls that directory, and then it runs each of those SPARQL like files against the ontology in the turtle file. Yeah, like a built-in endpoint. Well, it's like a local built-in endpoint. Okay, so SPARQL. What is SPARQL? Recall the semantic web stack. RDFS, RDF, OWL, etc. Here we have a query language, SPARQL. It stands for SPARQL Protocol and RDF Query Language because it's recursive. And, I guess people thought that was funny. I don't. But putting that aside, SPARQL is a core semantic web technology. It is a query language for RDF and a protocol for transmitting queries over HTTP. This is important. That last thing I said is what distinguishes one of the major things that distinguishes SPARQL from SQL. What do I mean, though, by query language? So database query languages, they're languages that are used to extract and manipulate data from information systems. And traditionally, data was often stored in relational databases where you have kind of like strict constraints on things relating to other things, but not so much explicit semantics and how that allowed for reasoning over those sorts of relationships without like doing a lot of manipulation of the columns and the rows so that you can join things and whatnot. They're fixed, though, is the important part. They're built on this closed world assumption, which OWL rejects. Namely, if you don't say something's false. So that's rejected. But they're somewhat easy to use to query with languages like SQL. And there's a whole bunch of resources around SQL. And there are also a whole bunch of relational databases on which people can reason or extract information from. Again, what I'm saying here, please do not take away me suggesting that relational databases are not valuable or SQL is not valuable. They absolutely are valuable. They're very good for various purposes, like quick information extraction, when you don't need to do a lot of joins or do federated querying across databases that can be incredibly fast and foundational for a lot of contemporary architecture. So not knocking them. And in fact, a lot of ontology pipelines at some point use relational databases. So we take advantage of both technologies. There's no reason why we should draw lines, use what works. RDF databases, in contrast, though, they're a little more flexible. They adopt this open world assumption. And because of that, the querying requires a language that is suited to these features. So this is SPARQL. This is some of the motivation for having SPARQL. It's a language for querying RDF databases. It shares a lot in common with SQL, but it focuses on what users want to know about the data rather than how the data is structured, which is more within the domain of SQL. It is a protocol language. So what is that? So SPARQL is a protocol that specifies how to send queries over the web to endpoints on the web through HTTP requests. A protocol in this context is just a set of rules that prescribe how parties communicate. And HTTP, as you probably know, is a protocol defined between, or that defines how communication works between clients, software that reads data from a server, and a server where the data is stored. We got to have some way of coordinating communication from like me, my computer, over the web. We got to agree on some standards. HTTP, one of the ways we do this. SPARQL leverages that. So where HTTP was a request response protocol, where a client has to send a request for data before the server will respond with that data, having these sorts of methods that can be leveraged to do things like getting things, posting things, putting things, deleting things, patching things, retrieving resource headers, etc. SPARQL can do some of those things, which allows it to move outside the scope when it's querying of your local database environment through the web to other databases. When I say you can like federate in your querying, what I mean when you're using SPARQL to do that is you can use the web to connect up to other databases that are not on your machine. What this means, the data exposed by SPARQL on any server can be queried by any SPARQL client, assuming it is in fact exposed. In contrast, query languages like SQL are focused on local query. They're not native. This is not to say that you can't use SPARQL with some other features to connect through browser. Of course you can, like there are various ways to do this, but natively SPARQL is built to do this. SQL is not. SPARQL allows, for example, combining data from many different sources dynamically through your browser, again, natively. Which incidentally, if I can get on the pedestal for just 2 seconds, there's a lot of like talk of like SQL injections and attacks. You know, people talk about SQL injections all the time. SQL injections are ways to like use SQL to like extract information from databases by like tricking the language or inputting like clever combinations of the query so that you can get information from a database that's presumably supposed to be behind closed doors and off limits. You know, you can use clever queries to get that info out. That's great. There have been a lot of analogies, some papers written about the comparing how you can also construct SPARQL injections. But none of them talk about how SPARQL is a native protocol language, which raises a whole bigger attack surface. What those papers do discuss is how you can just kind of simulate the same sort of SQL injections using SPARQL. And then they limit their attention to just saying, look, you can do this in SQL. You can do the same thing in SPARQL. And then they don't talk about the other features that SPARQL has that might make it a little more dangerous. By a little more dangerous, I know it's dangerous. That aside, I just want to put that bug in your ear. SPARQL, cybersecurity research around that, while paralleling the SQL cybersecurity research is, there's a lot more to do. Anyway, putting that aside, I said a protocol for transmitting queries over HTTP. Here's the structure, or some of the structure those queries take. Let me walk through this so you know what this means. In queries, when you're writing them, you will declare a namespace, likely more than one namespace. This is mostly for legibility. Remember when we were talking about the different serializations of RDF, we had like RDF XML, we had like N3, we had Turtle, and some of these were easier to read than others, right? Some of them were quite long and complicated. One of the features of Turtle, though, is you could introduce like abbreviations for lengthy URLs or IRIs that look like that, so you didn't have to look at them again later in the query. You can do that here in SPARQL as well. So all you have to do is use this prefix keyword. You can introduce basically abbreviations for namespaces so they don't have to populate down in your query. You also use the select keyword that says return any data. Those question marks are variables. They indicate that you're looking at a variable. Return any data subject or subject, label. Now you don't know anything about these variables yet. Common practice is to label or create variable names that are indicative of what you're looking for. That's just for you. Strictly speaking, this could be X and Y. If you're curious about why there's question marks here, it's from Prolog. You can blame Prolog. It's Prolog style variables. Return any data. Use this where clause then to say that satisfies the conditions. In this case, the subject bears RDFS label to some label. I said something, strictly, this is something bears RDFS label to something. Because those are variables, right? Could be anything. Altogether, prefix, declaring RDFS namespace, so you don't have to put that URL down here. If you see RDFS with a colon. If you wrote this out without the prefix, you'd have to write all that HTTP stuff, put it right there in the query. That's messy looking. So declare your namespace and you say, give me the data, any of the data that satisfies the condition, something bears an RDFS label to something. The way this works is it's graph matching. You've described a graph right here, something RDFS label something. And now you're saying any instance in the graph, anything in the graph that matches that pattern, give me that in a list. Where specifies the data to pull out, and the select picks which data to display. Where tells you the conditions to satisfy. You don't have to put everything you mentioned here in the where clause in the select line. If I just want to look at the labels, I just get rid of the question mark subject, and what will be displayed is just a list of the labels. Does that make sense? This was from the Virtuoso SPARQL query editor. It's online. You can check it out. There's the endpoint. So that's where you could look at it through your browser. I just put this query in. I have the prefix there, select. I put distinct in because I didn't want duplicates populating up. Sometimes you get the same match over and over again. Distinct subject label, where the subject RDFS label. And I said limit my results to 10 because it would go on for a while. And this is what's returned. You see, I said return subject. So I've got a header that says subject. This is return label, so I've got a header that says wage. And these are the things that match that pattern. Equivalent class has an RDFS label, quote, equivalent class, quote. Does that make sense? Now, graph matching, straightforward graph matching of the sort that I just described is it'll only take you so far. We often want to do what you might think of as conditional graph matching. So what I've just described up until now with SPARQL logically is kind of unsophisticated. It's just simple pattern matching, simple graph matching. We introduce with this optional clause, basically material conditional logic. If you're thinking of this in first order representations, like raises the complexity significantly. This actually optional clauses can really bog down your queries, especially if you're running queries over a significant, like a very substantial size knowledge graph or ontology, because it's looking for if this happens, then that. And what do I mean? So because basic units of RDF is a triple, SPARQL queries by default return only triples that satisfy the conditions in the where clause. I'm always looking for triples. Partial matches are not returned by default. For example, you might want to return the birth and death dates of everybody in a database. Like subject, birthday, death date. Return those or return whatever satisfies in the where clause those variables. Now the subject, in this case, example, I just put EX, that's my example prefix. Example has birthday, some birthday. Example has death day, some death day. I've leveraged some of the simplifying notation here in SPARQL query. I put a semicolon, which just means that this is just a way to abbreviate subject here, but you could strictly speaking read this as question mark subject X has birthday, question mark birthday, period. question mark subject, X has death day, question mark death day, period. That would mean the same thing. The semicolon just lets you abbreviate. But think about what I just said. The subject has both of these, both death day and birthday. That's what I'm trying to query. It's a graph that looks like that. It's a single thing that points to a birthday and death day. Anything that doesn't have both gets lost. Suppose the database is of my family and includes my grandmother's birthday and death day. She will be returned. But it will only return information for individuals that have both birthdays and death days. It's plausible, though, you might want to return individuals and their birthdays even if they're still alive. Optional allows you to do that. Again, it's like an if this happens clause. It returns everyone with a birthday in this case. If they have a death day, return that too. Presumably, they all have birthdays. For Benjamin Buttoning, I don't really know how the logic of that movie worked, but you see what I'm saying. So, but in this case, what we have is a subject that the thing that will for sure be matched is the subject having a birthday. And then optionally, if they have a death day, return that too. So now you'll get a list of things, a list of instances, and you'll have birthday, death day for some of them, presumably. You'll just have birthday for some of them, presumably, and an empty cell for death day for some. That's not the only resources we should take advantage of here. You know, select is powerful. Just return these things that match, blah, blah, blah. But you might want to filter logically a little more precision. Well, there's a filter keyword that restricts the conditions in the where clause using Boolean logic. And also some sophisticated functions if you want to query something that requires more than basic Boolean logic, which is quite often the case. So here's an example. So again, I've just declared this sample namespace. It's example.com. It's where I keep all my blogs. I've got select these variables. I want you to return what satisfies or this whatever conditions involve these variables. Now, where someone is a person with a name and an age, but not just any age. I just want the people who are over 18. So the filter clause lets me use a little bit of logic, and in this case, leverage some of the logic built into data types to say of the person, of those people with name and age, all of those, just focus on the ones that have age. You see, these are the same variable. It's going to be a number. The question mark age is going to be a number here. That's where the logic works. So integer greater than or equal to 18. Because there's logic built into XSD integer. Remember, it's like an ordering built into that. This greater than or equal to can leverage that comparison and just return what's true, namely of those ages that are above 18.
Is this why you want to have data types being expressed towards instances? For example, if everybody in the system had a data type of their birth year, then you could extrapolate this easily. But you would need to have this in your model. Is this like a good example of where you would use data types?
That's right. That's right. Absolutely. You can assert this and then leverage that in the queries. Yeah, Michael.
Yeah, dumb question. Why do we need access the integer here? Is that necessary?
Yeah, so the XSD is I didn't put the prefix in because I forgot to, but usually typically for this actually to work, because it's not built into the endpoint, it's directly, I need to put prefix XSD, and then I'd have the link to like the preceding IRI portion with a / that says integer. I wouldn't put the / integer, I would just the colon integer. But essentially this is an abbreviation for that longer IRI. A good point. He got me because I didn't declare the namespace. I should have. I should have really used that as a learning moment. Like, how come you didn't notice that? No. But good. Does that make sense? Okay. Here's some other things you can do with filter. Like I said, Boolean. You can do comparisons. You can do conjunctions, you can combine things in the filter clause. So 18 and like greater than 18, integer greater than 18 age, but you know, not over 70, something like that. You can also test in your filter clause and say, just return, I only want you to return things that are URIs, right? You can also say things like, you can return blank nodes is blank. Or you can put this not operator in front of this and say, not is blank. Don't return blank nodes. You can also say, just return literals, or you can say, if something is bound from the where clause, return that. If not, return that, stuff like that. You'll actually see that in just a second when I look back at that example of the English definition, SPARQL query. You can also leverage these keywords in the filter clause. You can talk about years and months and minutes and seconds and now. So these are like XSD date times that are being leveraged in the background. Ah, look at that. Greater than 18, less than 25. Filter functions restrict things further. So I didn't mention regular expressions because they're nasty. But built into SPARQL, you can use regex, which is essentially a way to filter. It's a function that filters on strings. So you can look for specific strings, like the actual symbols. So this, for instance, this regex filter will look for any string that has hello in it. And that I there means ignore capitalization. So it could be all caps hello, and it will still return. If you don't put that in, that I in, it will just return any literal lowercase hello. But this can be potentially very powerful when you're writing filter queries. You combine this with logical operators, combine this with other filter or clauses that you have here, get really fine grained with your regex. Let generative AI do it. So back to where we started, right? Declared namespace in this query is focusing on definitions and having minimum definitions. Also declared the return variables. I wanted to see something like resource, label, and this question mark error, which I'll talk about in a second. I didn't mention the values clause, but this values is a keyword. Essentially, it means that the variable, that question mark variable type, ranges over everything in the brackets. So if I use it later, like I do here, resource a type, what this means is for any resource that's a class or an object property, bring those back. I want you to return those. I want to point out a bit of the logic here. This is why I included this example. You can do what I've just described with the values by saying check if it's a class, check if it's an object property, by writing the where clause to say if it's a type class, if this resource is of type class, return that union if it's a type object property. So you can use, there's a union operator. You can, this description logic based, you can say bring me everything that matches this graph, or i.e. union everything that matches this graph. That is computationally expensive in almost every environment you would run this against, because it first checks this graph and then checks this graph and then puts them together. The values clause was introduced because it checks them simultaneously. So instead of two iterations that are then combined, it checks. It just does one as it proceeds to. So I will always encourage you, in the sake of computational complexity, use values. This is especially true if you're running reasoners over large graphs. And in my experience, my actual work experience, I was able to bring down the complexity in querying for some companies I work for significantly by introducing just values clauses. So just use those, yeah.
How important is keeping in mind times and the computational complexity and so on of what we're doing?
For you guys, not much. When you start working, it'll be a lot more important. So it's good to get some of that stuff back or down in your back pocket now. And we're gonna get you up to speed on where it's valuable and it's not. But this is one of the points to keep in mind, right? If you can use a values clause, use a values clause. And as we proceed through creating SPARQL queries, I'm gonna keep pointing out time savers. But in answer to your question though, right now as you're working in the open space, not that big of a deal. You start working with a company, start working with like the government or something, you're gonna see very large knowledge graphs, very large like ontologies that you're running queries against. It becomes very important to optimize your queries. So I've got an optional clause here. Optional return resources, even if the definition's missing. In fact, that's what I'm looking for because this is a quality control check. Or if it's missing an English language tag. So resources of the type class or object property. You go ahead and return them if they're missing definitions or a tag. But indeed, keep only the results that don't have a definition. Right? Because what I'm looking for are violations of you must have a definition requirement. So again, I'm saying, look at all the OWL classes, all the object properties. I want you to return optionally, if they don't have a definition and they don't have any, or they don't have an English data, a tag, go ahead and return that. But only keep the ones that don't have a definition. That's what that exclamation point, not found, is doing. So this filter is saying, if there's nothing binding the variable English definition, keep that. Alternatively, if I didn't put that exclamation point, this filter would exclude everything that didn't have a definition. It would just give me the stuff that had been bound to the definition or English definition variable, and it would filter and keep just those. So saying not was important because that's what I'm aiming for. Now, of course,
John, I
I
have a question.
here don't include, what's up?
A question.
Yeah.
So I know you can run a SPARQL query to make sure that like definitions have a period at the end.
Mm-hmm.
Is there a way to run a SPARQL query to make sure that definitions are written in a genus species form?
Yeah, I think Giacomo made one, didn't you?
Into what?
Didn't you create a query that checked if there were genus species formats?
Yes, and checks whether the genus and species correspond to the, so basically if it's Aristotelian. form.
Yeah. Yeah, so Giacomo is
What is it doing, Giacomo? Is it checking to make sure that the parent class is the first thing in the statement?
Yeah, he's shaking his head, yeah.
And then
Very
whether the third term in the second or third term in the statement or whatever, at a certain point you have a term in the statement telling you the name of the class itself. Because normally if you have an Aristotelian definition, you have something like, I don't know, a person is a material object that,
Mm-hmm.
so I'm checking to see whether it says a person, material object, that or where or which.
Mm-hmm.
It's not perfect, obviously, but it's
Sure,
something.
sure. Yeah.
But it's in Python, I believe. I don't think it's SPARQL.
Oh, it's not SPARQL query said. He's got a script that checks this. In Python.
Oh, okay. All
Got it.
right.
If I could
yeah.
see, you could write a query for this.
Because that would be interesting because we always started with like, and parent class
Mm-hmm.
that blah, 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 blah. That's how we write ours.
Yeah.
That would be
no,
a great
good.
thing to have. All right,
All right.
cool.
I'm glad you said that, because guess what you guys are going to be doing. Before I get there, what's going on here in this last, right before order, but bind. I am saying, return. I want you to return something for this error value, this error variable that looks like this. I want you to bind the following: concatenation. Just put these strings together. Warning: missing definition for space, comma, string resource. I want the string version of the resource. So I don't want an IRI. I want you to tell me what the string is. And then all of that concatenated together. And I want you to bind that, i.e. return that as the error. So I don't want, like I do want you to tell, I do want this to return the resource and the label, but I also want to return this error that says, warning, missing definition for this thing. Does that make sense? Oh yeah, no, ignore blank notes. Wait, that should be a little lower. Because that's not what that's doing. Format results with a description of the error. As you investigate the Common Core repository, you'll note there are not many SPARQL queries being run against builds. I've added a few. I have more to add. If there's only some group of individuals that either already knew or was willing to learn SPARQL. We'll get there. That's you, by the way. We'll get there. But first, we should practice what we've just discussed. Here's a challenge. Do you know what DBpedia is? DBpedia is this huge database, linked database that is essentially intermittently built off of Wikipedia. They take content from Wikipedia. They have been doing this for years, so it predates Wikidata. They've been taking content in little boxes or whatnot from Wikipedia, and they just generate RDF out of that. And then they put it on this website, dbpedia.org. And they update it every, like twice a year, I think. And they have all sorts of information, like connected information. They've got like an interesting user interface. Giacomo's looks like it's very ugly. Some people do. Carter does. He has a blog post on my blog about how ugly it is. Well, like technically, like formally ugly. But importantly, they have an endpoint, a SPARQL endpoint that you can use to query the data. It's right there in the link, the dbpedia.org/SPARQL. So you can go there, and you should go there. You can navigate. And I want you to do the following. Figure out what the birth date is of Barack Obama. We'll start there. It's in there.
Just a quick question for the beginning.
Yep.
So, because this was not immediately clear to me when I started doing this thing last year,
Pro tip.
2 years ago. You need an endpoint to be set up to run your queries against. So you need some server-ish structure to send your SPARQL request to.
Yep.
So right now we're doing it against this thing, which is a website, which is storing this information taken from Wikipedia.
Yep.
Now, sometimes what I did, there's like an extension for VS Code that lets you run SPARQL queries against local RDF files.
Yep.
And we just went through Robot, which lets you do the same. But normally, how would you do that if you do not have Virtuoso or DBpedia and you do not have your local file? Where else would you run your SPARQL query against? If you're not using like VS Code extensions, you're not using Robot, you're not using DBpedia.
I feel like you've exhausted the options. Yeah.
Would
You have to have an.
something?
You have to have, well, even there, that's going to fall into these options, right? Like you have to have an exposed server, like an exposed endpoint for the data. And by exposed, I mean something that you can use SPARQL against. So not just like you can access it somehow, right? Either an API or like a graphical interface or something like that. What you're doing with VS Code is you're kind of simulating this. You're putting a database on your local environment. You're running queries against that. You could do the DBpedia challenge there if you wanted to download all of DBpedia. Don't do that. But yeah, but Robot is operating the same way. Like it's creating a local environment, querying against it. So you're always going to need that kind of infrastructure. Now, when you're doing it in a local environment, you're not, of course, leveraging any of the protocol aspect. But here you are, right? Because you're running query. You could in your local environment, like write a query, write code that calls the web browser, opens a browser, or maybe opens it implicitly or like under the hood, runs a query, returns back results. As a matter of fact, there are packages that do such things. And to put that another way, just maybe if you're more familiar with some other like more SQL-y stuff, like there is a Twitter library, a Twitter Python library you can download, and you can say return all of the posts that mention this thing over this period. And what's going on is there's an API that allows this code to look in and explore the data set, return pattern matches based on your query. And in this case, of course, there's like a infrastructure setup that's not native to the language you're using, but allows you to do something very similar. But in every case, even those sorts of cases, you're going to have some database, some query language you're using to extract information from it based on your standards. And then like it populating either in your browser or your local device or something. Did that answer your question?
Yeah.
Okay. Good question.
Well,
It's almost like you took this one. Are there any other questions? I know I was like, what is the birth date of Barack Obama? You could probably just Google this. I want you to return a result.
John, are we supposed to tell you what the result is?
I want you to tell me what the query is.
You want me to put, yeah, you want to put it in the chat?
Sure. Here's what I want you to do. Put it in the chat and then have one of your teammates check it.
Ooh, okay. Here we go.
Limit 1. Somebody check it.
It works.
All right. What's his birthday?
1961, August 4th.
Good for him. Here we go.
John, have you looked at our PRs?
I have just briefly.
Okay.
I like what I'm seeing.
Okay.
As you can see, there are many other questions to answer. Some of these are a little more challenging than others. Go forth. I want queries. Delicious, delicious queries. Some of these aren't going to be obvious in the sense that you may not, and you'll find this very acutely in a moment, you may not know which object properties or classes are available. You could make up your object properties. Oh, highest peak? Sure, I'll make up an object. Release date? Sure. I'll just type in release date and see if anything returns. You have to have it exactly correct. You have to use the name that DBpedia uses to label.
Remember we did that over the summer,
Yeah.
and some of the stuff DBpedia has is wacko.
Yeah. Just pull from.
So how do you address that? Do you have to become an expert in DBpedia?
God, no, that's crazy.
That's I'm asking.
Oh, I don't know,
What, we
guys.
just-
You want to help him
Okay.
out?
We just come up with another word for highest mountain? I
No,
mean, just
no.
trial and error?
No. There's got to be another way.
Well, you
Yeah.
can make you can you can try to map it to CCO and make equivalency classes.
Yeah, there's one way. Although CCO, I don't think is in DBpedia, so you're gonna
No,
want
it's not. So if you wanted to use, like if you knew how to make the statement inside of CCO, you could make the statement and make equivalency classes.
That's true. That's true. But then you still need to be equivalent to something, and that would be the language of DBpedia.
Exactly.
You
Yeah.
still need to know that language. But there are ways. So DBpedia is not just an endpoint. Like you could use the endpoint and run queries against it to explore the sort of object properties that they have, right? You could, for example, write a query that says, give me all your object properties. That's going to be a big query. It's going to return a lot. You can put a limit on it. That's one way you might explore. You could think about more creative, more refined queries to get closer and closer about the sort of vocabulary they're using. Or you could just go to the DBpedia page and start poking around because they got a cool graphical user interface that lists their object properties. You can kind of like search around. There's some options, right? I suggest all of those, really. That would be it. I think all of those are going to be useful. Some of these questions might require you to do both of those things I just said. But hey, it's the journey, right? Not just the destination. Sorry, Josh is asking me a question. What's up?
I was just curious why for a SPARQL query, just real quick, sure.
Yeah, John, where'd you get that hyperlink?
Everything here.
Oh, because DBR, because it's a reach.
Sorry, I stepped away. What's that?
No, you were asked where you got that hyperlink, baby.
Yeah, I
Oh,
was trying to figure out
just-
how you knew to insert that or where you pulled that from.
Great question.
It just produced it in the result.
Wait, what? Yeah,
And then this example of resource. This,
what just produced it?
DBpedia.
so you have to go through.
Oh, so then I'm looking at your result, not your SPARQL query.
You have to.
I'm looking at SPARQL query.
Oh, yeah. Yeah,
Okay.
yeah.
Where'd you get the link from? Or how'd you know to use a link in your query?
I didn't. I used ChatGPT.
Oh, it knew it for you. That's smart.
Did you check the link to see if it worked? If it goes, because if you click on the link, it should take you to a DBpedia page for Jurassic Park.
Resource was the last one.
I ran the SPARQL query and it worked.
All right.
Yeah, Steven Spielberg. But
Well, how do you get the link though?
Where we.
This is good.
And that way it would show me.
So I
Oh,
I can elaborate though if you want. So like what you're querying are essentially a bunch of links like that. And you hide some of them with prefixes, but strictly speaking, you're just querying a bunch of like IRIs and links. And so that one happened to the ChatGPT happened to know enough about DBpedia to say, if I'm looking to answer like who the director of this movie is, I know I'm going to need to pull that link. And they did, the GPT didn't introduce a prefix for it, just use the link directly.
All of this.
Does that make sense?
So.
all right.
yeah, yeah, it makes sense. But if you do it without it, it didn't give me the answer.
Yeah, you could do the following. You could adjust it so it looks more similar to the queries I've been illustrating in the following way. If you introduce a prefix and then you say put in an abbreviation for DBpedia that's like DBO, lowercase dbo colon, and then you put that HTTP all the way up to that last forward slash in that as that prefix, then you can go down into the where clause and you can replace those corner brackets. You can remove those, and then you can remove that whole HTTP all the way up to that resource forward slash, and then instead replace that with DBO lowercase colon, and then the query should return the same. And I've essentially just described how you can use prefixing to create abbreviations for those links, so you don't have to look at them.
Yeah, because I did.
So John, Jeremy had a really interesting thing with prompt engineering.
Mhm.
He was trying to get it so that it would have like, it would do things resolutely.
Mhm.
And he had to explain it to him. He had to explain to the GPT, this is law. So you go into your GPT and you're like, this is law.
Mhm.
Always use BFO as your top level ontology. Then it will set itself. It'll commit it to memory and it'll only use it. It's very interesting. You can actually help with like it returning garbage to you by telling.
So it might. So Carter actually wrote he like researched this for like 6 months. And what he found is that it will as a default try to use BFO, but as soon as the prompts get even kind of complicated, it starts making stuff up. So it will but there's a noticeable preference for like abiding by the law. It's just
No, I'm just trying to. The queries are very similar to that of SQL. I'm just trying to like understand the passing of the URL into the query itself, and because I did it similar to SQL and just abbreviated stuff, so understanding the difference would be useful.
You're saying in your queries you're writing more like SQL.
Yeah.
Yeah. This looks sparkly to me. Release date where DBR Dark Knight, DBO release date. This is this is the way I would write my SPARQL, in that I'm using like DBR as an abbreviation for the longer link. Same with
Yeah.
DBO. Yeah, and that's valid syntax, but you don't have to. You could use like the full, whatever the DBR is abbreviating, you could put that directly into the query, as John did when he entered that DBpedia /resource /Jurassic Park film link. Yeah, either way.
What-
Did you guys answer all the questions?
I'm trying to.
Yeah, I did.
I still haven't found one for the director.
Okay. If you
Letting
know,
aside, going to ChatGPT, I can pull it up too, but I still don't understand if you remove that URI or the
Mhm.
URL, excuse me, what
Yep.
the proper construction is.
I keep getting for the World
Yeah, it
Cup.
just comes back as director.
Mhm.
Yeah, I keep getting winner.
How
I'm doing
about, so those of you, so some of you have solved this. Explain.
So the way I solved mine was using the DBRO of the resources, and then basically checking if I have a winner, it returns the winner, or if there's no winner, it just says winner.
No, I don't know what.
Yeah, but that Obi, yours that you put into chat, it just says winner. It doesn't say France. I have the
Oh,
same problem with the World Cup one. Yours is saying winner. That's all I'm getting. I've done it like 4 different times. It just says winner.
Hold on.
Then I tried to have ChatGPT do it, and then it did the same.
Now let me do this.
You must have. Here, G Stu's gonna share her screen. She want to show you something.
So I asked ChatGPT to write a query for the highest peak in the US. And then so what I got was all the lakes in the United States that has some elevation. So yeah, so this is actually a lake that has certain elevation.
But check this out. Here's why I wanted her to show you. So Jisoo clicked on this link and it took her to this DBpedia page. There are a bunch of links. If you go back to your query again, you'll see one more. You'll see she's used DBO : elevation. So this is the object property that she's trying to search on. Okay, execute it again. All right, now click on Pacific Tarn at the top. Observe on the right, on the left-hand column, you have properties. One of them is elevation. Click on that. You just found one of the object properties that they use. And there's a whole bunch of information about it. And you can do that with all the object properties. You can look at, this one has label, range, etc. If you go back, you'll see a whole mess of object properties that are right there on the page.
Interesting.
Yeah, use this to figure out what object properties DBpedia is using that you can query on.
Oh, so that's how you build what you're looking for, right? So if it's,
That's
film, then underscore name of film or something. Okay.
That's right.
I recently found the highest lake in the United States. It's instead of highest peak. Yeah.
Okay.
Is that because you're missing mountain or like the highest element?
It
It looks like you're just saying, give me a peak with any elevation.
Yeah, I did include peak, but I think actually the error comes from elevation.
Like it's not.
Because
But I think Tim's right. You need to qualify that it's the highest elevation in the United States.
yeah, so I think that's what the limit is doing. So it's ordered by descending height.
Okay.
Oh, okay.
Limit
should
is
go to the
1,
bottom.
so then I get just one thing, which is a wrong thing, which is the highest lake with highest elevation in the United States. So
But
maybe
you're not
it's
asking for a mountain, right? Or you're not asking for highest. You're just asking for a peak with any elevation,
yeah, but
right? And but you're looking for the highest mountain.
Well, do we know that peak in DBpedia means highest mountain?
I
don't know.
think I would assume I thought that peak would imply like the highest point of a mountain, but apparently it doesn't think like that.
You're using the question mark before peak, so it doesn't matter what you write after that. You could call it it doesn't change anything.
Yeah.
So the only thing which are relevant here are DBO location, DBR United States, and DBO elevation.
Yeah.
All the things with question marks are just for your own understanding.
Okay.
There's no mountains. You have to at
Yeah,
some
there's
point
no mountain.
you have to have
Okay.
the physical object you're querying about, right? In your where
Yeah.
statement. Right? So it's not a peak. You're actually
Okay.
looking for like a hill or a mountain or whatever they call them.
Has
Okay.
it never did it return Southern Rocky Mountains?
No,
My
it gave
No,
us
that would be a
Well,
mountain
so-
range. It would have to return something like Baldy Peak or something. It would have to
Oh.
turn like, you know, an
Mountain Peak?
actual
What
mountain.
about
So I think what you need to know is you need to know what does DBpedia use to call mountain peaks.
how do you
Right.
search
here if you run that query and then you
Yeah,
go to
my
the link
query,
that it
my query
produces,
brought out the one.
and scroll down under highest, it says Mount Elbert.
So elevation. But the DI URL is what gives us the location, right? What is it without the without the URL?
Here, right here.
So the DBpedia resource United States gives us like the location where we're targeting, right? How would we do
Right.
that without that link? What is the DBR? Is it DBR United States?
What do you think?
What?
So there. So without this, do we do DBR United States? Because I think I tried DBR United States and then it didn't work or something.
Because you're qualifying, it's only United States, right? You're like, that's what we want to say.
Oh, let me try.
Wait, the point is DBO country a relation at all? DBO
What
country
is
is that a
DBO
relation?
for?
DBpedia ontology.
Yeah, but you have to check whether that is a relation or not.
Oh, I don't know.
Sounds like a good one.
Oh,
Looks like a class.
And remember, countries are really weird in ontologies, you know, like you have the fiat boundary of a country, you have country is not really one thing. John and I have actually talked about this in
Yeah, but in this case, it's probably country name, right? I don't think they're going to be.
I don't know. That's all I'm saying is I don't.
Let me try to No, go back. So
Why
here
don't
it
you
seems
look up
that
the United States and then you can look it up. Look up the United States.
click on United States. It's DBR United States.
Okay.
And it seems like go down. Does it have like something like highest peak, perhaps? Well, it does have DBO largest city, population density.
this is at the end of the
Okay,
page.
go back. I mean, with the previous page.
Oh,
Just remove DBO name.
It's this one. Oh no, it was this one. Sorry,
it's still.
loading.
Yeah. Oh, my browser is sometimes.
I'm not sure it's the browser. I think it's just yeah, this is computationally heavy on DBpedia servers.
Okay, this you got something.
But it was saying that the lake was connected to, yeah, don't do that.
Oh,
Jeez. it was saying that the lake you have, or even this one, say DBO country, so it is a property. So I think that's correct.
Okay.
And you also have the DBR, go back again. You also have DBR United States, so you can just copy paste this.
Okay.
So go back to the query. So right now it's looking for things which are in the country United States and which have an elevation. And what was the result of this? It's only one thing?
Yeah, because I limited.
Oh, okay, okay. And I assume this is not the ISP.
It's
Or is
a,
it?
it's a mountain range.
It's not a
Be a
region.
mountain range, it's a peak, it's gotta be a peak. And it's probably, I think it's either in Alaska or it's like Mount Rainier.
Yeah, I think
We
it's
do have
I think it's
the
Denali
highest,
in Alaska.
Mount Albert.
No, I think
the-
I think it's Denali in Alaska.
Oh,
Yeah, okay, but like DBO, what's DBO highest? Can you click on that?
yeah.
The highest mountain of a mountain range.
Uh,
You want the mountain, not the mountain range.
And the range is DBO mountain, so you know that there is a DBO mountain here. So go back to the query. Yeah. So now you know we're looking for a mountain here.
Here?
So you, yeah, but like actually click DBO mountain. And take away that. And now, well, but now we still have like right peaks over, so I guess peak, no, because now it's 4 entities, so you have to write something like peak at DBO mountain, and then DBO mountain, DBO country, United States, or something like that.
What about, so get rid of
Can I
country?
try?
Yeah.
No, just, pick, a deep, oh, what's this spelled? Jeez.
Same way it's or SQL.
Name e appunto il name questi sono i field praticamente.
Are we still screen sharing? Oh, sorry, this is embarrassing.
Do you need country in there, or can you just say go straight to the United States?
Le cose da provare.
You don't really care about any other country, but United States, you're already qualifying.
So,
I'm not sure I followed. Could you say that again?
I don't think you need country in there because you're already qualifying it with the United States. You don't care about any other country in this query.
Yeah, but country is the relation which goes to United States.
Oh, okay. I got you. Why is it coming back with mountain range? It's really weird.
Also true if they're using
Ok, praticamente questi sono i fields.
See what type of, it's the type of place. Really? Okay.
Field.
Oh, highest is there. Here you go. DBO highest, right?
Your highest comes
Right
up
there.
with Mount Albert.
Yes, but this is the highest mountain of a mountain range. So we
Yeah.
should find the mountain range first, probably.
Well, it gets us closer.
Well, the thing is how does it qualify what the highest mountain range is? Does it qualify it because it has the highest peak? Or does it qualify because it has the highest amount of average peaks?
That one's really specific.
I have no idea.
You know what I mean?
That's
You know what I mean? Like
underspecified.
if you have 90 mountains in a range and 89 of them are very, very short, and one of them is just the highest peak, they're not going to be the highest range necessarily, depending upon how it qualifies what the highest range is, compared to maybe Rockies that they're all pretty high.
So what about this? So like where a peak is a DBO mountain and
Yeah, I was wondering, like, rather than having to flip back
And
and
the-
forth between, like,
peak is in the United States and has a certain elevation.
The schema. Yeah, just the whole.
What about the highest? You have to add the highest, right? That's the qualifier.
Well, but that only accounts for, oh, because maybe DBO elevation only goes for mountain ranges. We didn't know that. Um, highest works for mountain ranges, right? So it connects the mountain to the mountain ranges of which they are the highest.
Okay.
So we can have it. Pretty easily, but it is an addition.
I wonder what I did wrong here. Let me just take this away from.
We're doing it wrong.
Well,
We need to qualify what has the highest, what peak has the highest altitude. If we do that, then we'll get Denali at 20,310
Why altitude, not elevation?
or elevation, doesn't matter, elevation or.
I think
Depends on how it's
altitude is
defined.
right.
Depends on how you define, how they're defining
Depends on how you're
elevation.
defining,
and
but
altitude.
the way
I
we're
think-
going right now is just showing us mountain ranges. We want to get out of mountain ranges. I don't know why DBPD is doing that. John gave us a squirrely one here. Did this on-
Shocking.
John's
Shocking.
trying to show us that ChatGPT can't do everything.
Yeah.
probably.
Exactly.
Because it means that we can still have jobs.
Yeah, but what is the problem here?
But even if we run the query that I just put in chat, if you run that, it does it by elevation, but for some reason Denali's not in there.
Hey, no, but why don't you look up Denali and DBPD and see how Denali is traded? Done that? Sue?
My brain is trying.
Have we looked at Denali?
I'm trying to get some credits transferred.
Simon, what is this?
Really?
I ran yours, John, and it gave me a bunch of stuff. I don't think they're in the US.
No, yeah, they are not in.
No, that's
This
not.
is not in US.
I know. It's not weird.
That's in
You have to
India.
get back the country, go back.
Syracuse
back.
classes with the- I took them and then I just remembered.
Yeah,
You
there's
gotta
like-
write a mountain,
Just like-
Mountain name.
To
a
trans-
DBO country.
Where's the nation? Where's the United States in there?
Yeah.
Yeah, something like this.
Yeah, add, we have to add US.
DBR United States, something
Yep.
like that.
Yes.
DBM.
Oh, DBO, sorry, not DOB. Let me see whether I got everything else right. So the mountain has an elevation and is in the United States. And it's also got a label, so this needs to be like this. And like this should work. And now I'm not getting it. Because probably they're not connecting mountains to the United States through this property here.
Maybe.
So let me try this one again.
I think is that Denali is part of the McKinley Mountain Ridge, right?
Yeah.
So maybe look for McKinley.
But what, but we should, but we don't know, but the problem with the.
Yeah, he's just trying to backtrack it though.
Oh, I know,
To
I
figure
know.
out, yeah.
Yeah, we're just trying to get.
Says
I don't know
trying
why
to
we're
start
not looking
somewhere.
at Denali in Wikipedia. I would look at Denali and see how they
City.
qualify.
What about ranking the elevation? Can we rank, order the results?
This is not working.
I mean this. I mean this line. Right here?
It is. 314.
Yeah.
Well, look at that, time to go.
Oh. We want
Thank
to
you.
finish this now.
Thank you so much. I appreciate your time and the effort you put into this, and I'll be reviewing your commits and your PRs in the leisure of my weekend.